All right, let's get started. Welcome to the presentation on Speed Without Discipline, a recipe for disaster. My name is Venkat Subramaniam. I want to talk a little bit about what I care about the most, which is to really deliver software that serves the needs of our customers. And in doing so, I work with a lot of different organizations. And when I go there, they often tell me, oh, Venkat, we are Agile. And these days, I often tell them, so glad we got that out of the way. Now let's talk about what you do. And one of the things that I'm keen about is not just speed, but I care about sustainable speed. So how can we really sustain the speed of Agile development? What are the things we have to do to make that happen? Well, I'm going to touch on one portion of that in this presentation today. But before we do that, let's talk about the latest buzz. As developers, we often are keenly interested in what's going on, what's that we are doing, what everybody else is doing. Well, I was kind of looking through what people are excited about. And of course, everybody talks about microservices today, isn't it? And that's the new rage, and you have to be doing microservices. And then, of course, we talk about big data. And then we talk about cloud computing. And then we talk about Docker. And then somebody said, no, that's going to be Moby. Keep changing. And then, of course, functional programming is really exciting these days. And Angular 2, oh, that's going to be 4. No, that's going to be 8. Keeps changing. And then, of course, IoT is big deal. And everybody is interested in AI and algorithms. Now, I know algorithms is really exciting because they use the word algorithm even in TV shows these days. So that's got to be really important then, isn't it? And then, of course, machine learning. And then somebody said, no, machine learning is not exciting anymore. It's actually advanced machine learning. And so these are the things we are just excited about, the next buzz. But what does it all mean, really? What are we trying to do? All we are trying to do is to raise the level of abstraction. That's what we do as human beings, is we raise the level of abstraction so it becomes easier for us to get our work done. But in raising the level of abstraction, we get one benefit, that we are able to focus on that higher level, but a lot of things have to be really taken care of to make sure things are actually still working. And in that regard, I think we are in the cusp of a major shift in our industry. And this shift has been going on for a few years now, but it's becoming even more prominent every day. Now, let's talk about the 90s just for a minute. I know that's a bit 30 years ago now. But what was the major shift in the 1990s? Well, the 1990s showed us the prominent shift from structured programming to object-oriented programming. I remember the 90s. I was a very young programmer back in time. And there was a constant fight between people. One group of people telling us OOP is awesome, and the other group of people telling us that OOP sucks, and programs will never work, and they'll be really slow. And then about middle of 90s, people quit talking about it. And everybody jumped on this bandwagon of OOP, and they started doing object-oriented programming, so much so we didn't even question it. It kind of became a de facto standard at that particular point. So the major shift at the time was going from structured programming to object-oriented programming. It was a major shift at that time. But of course, what is the latest buzz? What is the latest shift? What are people trying to do now, 30 years later? When it turns out that it's actually imperative to declarative style of programming. Now, you may look at this and say, really? Because what I heard was functional style of programming, not declarative, you may think. Well, I want to emphasize it's actually imperative to declarative more than really functional style of programming. So what does that even mean then? Well, imperative style of programming is where you focus on telling what to do, and you also tell how to do it. On the other hand, declarative style of programming is where you focus on what to do, not on how to do it. So you delegate the responsibility of how to underlying library of functions. So you are able to keep your focus on what you are trying to accomplish, and you leave the details to the lower levels of coding. Now, it turns out the reason why functional programming is so exciting is because functional programming is declarative. So it becomes a subset of declarative style of programming. So what in the world is functional programming in that regard? Well, it turns out functional programming is declarative style plus the use of higher order functions. So in a sense, what you're doing is you're building on the declarative nature, and then added to that, you're bringing in the ability to do higher order functions on top of that. So this is one of the reasons why functional programming shines really well, is because of its declarative nature. So it's imperative versus declarative. That is really the push right now. So considering imperative declarative, what does it all mean to us? I mentioned that imperative is where you tell what to do, and you also tell how to do it. And you have to spend all the time and effort giving every single step of the detail of what you need to do. Declarative, on the other hand, is where you're able to focus on what and not be dragged down by the details of how. Let's explore this just a little bit just to get a feel for it. So here is a little example I want to create. This is a code I'm going to write in JavaScript because almost everybody, understands JavaScript, so it doesn't matter what other language we use. So I'll use JavaScript as an example here. So I want to count the number of names in the given collection of names that are of length 4, right? So how do I do this? Well, here's how imperative style code is going to look like. I'm going to say count is equal to 0. That's a very first step. You have to initialize a variable. Now, when you initialize a variable, you give it a new value to begin with. Now, I know what you're thinking. You're thinking, well, I wouldn't call it count, you're thinking. What do we normally call it? We call it temp, or we call it t. Why? Because we tell the variable, you don't deserve to live. That's how we feel about variables, isn't it? These are called garbage variables. And this is a very symptomatic style of imperative style of programming where we will put in all these garbage variables in our code. But I'll give it a respectable name called count. Then what do? You say for, and you're going to say I is equal to 0, and then I less than, what is it going to be? Names dot, and then you kind of wonder, is it size? Is it length? Is it count? Well, it depends on the language you are using. And even within the language, it depends on the data structure you are using. Why? Because if it's consistent, we'll get done and go home. Cannot be consistent. So in this case, it's going to be length. But that's not enough, right? Then you pause and ask the question, is it less than or equal to? And do you ever ask this question? Every single time. And in fact, somebody asked me the other day, what is that symbol called? I said, that's a symbol, international symbol for confusion. Because every time you type it, you pause and say, huh? I'm not sure. And this is vexing, isn't it? You have to make this decision every single time you write the code. And then what do? You say I++, and then you pause and ask, is it plus plus I or I++? Now, notice how many moving parts we have in this code. And then to add insult to injury, how do you get the value out of it? Name square bracket 0, I, or is it get? Depends on the language and the API again. And then, of course, we say, in this case, if the name of that is length, and as for the length of it, is equal to 4. And then I know what you're thinking as a JavaScript programmer is a double equals or triple equals, right? You got to make all these decisions over and over and over. And then what do? Then you say count plus plus, or is it plus plus count? And then, of course, when you're done with it, you can display the count of this. Well, that is an example of imperative style of programming. I'm not going to ask you if you have ever written this code, because everyone has written this, isn't it? But I will ask you the question, how do you feel when you write code like this? I'll tell you how you feel. You feel absolutely dirty. You feel absolutely dirty. If you have to write this code for 10 hours a day, you feel dirty at the end of the day. You go home, the kids come running towards you, you say, don't touch me. I got to go shower first, right? That's how you feel, because it drags you down and beats you down, and you spend all this effort writing a lower level code. That is a style of imperative programming. So imperative programming is built with accidental complexity, and that's what we do. We have to suffer through this every single step of the way. Now, let's go a little further with this. Now, we could also do this in a declarative style of programming. How would that feel to write the code declarative? Let's get rid of all of that for a second. Just comment that out. what we can do instead is we can simply say names.filter. So we can start with this little filter function, and we are saying, well, given a particular name, simply give me a name whose length is equal to 4. So this gives you all the values that are of length 4, and you can ask for a count on it to find out how many you have. In this case, a length, of course, to get the length of it. Now, notice that it did not take as much time and effort to write this code. The code is a lot more expressive, easier to write as well. And that represents a more of a declarative and, of course, functional style of programming. So we are saying, I want to take these collection of data, but I want to filter out everything that doesn't match it, keep the ones that are satisfying the predicate, the condition, and then, of course, give me the length of it. Well, this, of course, how does it feel to write a code like this? Well, it feels like you're talking to a responsible adult. So you don't have to go through all the details. You leave out the details of how to do the filtering. These are called internal iterators, and you can keep your focus on this higher level of abstraction. So this was the declarative nature in writing the code. But I'm going to make the claim that we are moving towards declarative in almost everything we do as human beings. This is where we are heading. So in the code level, we saw declarativeness. But declarative is not just in writing the code. Declarative is in the front end today as well. For example, here is a little example of putting a little message on the view. So what is really creating a web application? Web application comes to really two things today when everything is said and done, isn't it? It is manipulating the DOM and making a call to the server using AJAX. So your life as a programmer for the front end is doing DOM manipulation and getting the data from the server. Now, when it comes to manipulating the DOM, how do you do that? Well, you can do document.getElement by ID. Well, I didn't even put the ID here. That should be there. And then, of course, you can say Tom. You can append to that, and then inner HTML. Now, that is manipulating the DOM. Let me ask you this question. How many of you have ever written code to manipulate the DOM before? I know. People are slowly raising the hand, right? The others who did not raise the hand, I fully understand. You never want to admit this in public. The brave ones did. Let me ask you a different question. Those of you who raised the hand, how many of you want to go home tonight and write more code to manipulate the DOM? Not a single hand went up, right? Why? Because after you do it a few times, you realize that the code to manipulate the DOM should be given to people in the prison. Nobody in the free world should be forced to do it, isn't it? Because this is such a low-level API. It drags you down. That is imperative style of programming. And that's a lot of effort. And I can never remember these API. And you type those, and it doesn't work, and you're frustrated, and you're not sure what to do. Well, what did we do in the past? Well, we said, gosh, you don't have to do all of that. We can just put a little dollar around it. And you know what that is? That's jQuery, of course. Now, what did jQuery do for us? Well, unfortunately, jQuery did not remove the problem. jQuery is still imperative. But jQuery is taking morphine. You reduce the pain, but the underlying problem is still there. So jQuery did not remove the problem from our shoulders. It just reduced the pain for the next few hours. But it's going to come back tomorrow again. And so that is still imperative style of programming. But today, what do? We want to be programming in React or Angular or Vue. What do those things do? So you don't write the code to manipulate the DOM. Instead, you say, hey, here is a DOM element, and here is the output. You go figure how to update the DOM. That is declarative style. So Angular and React and Vue are examples of declarative libraries, whereas DOM and jQuery are examples of imperative libraries. And so the world has pretty much moved away from doing things like DOM manipulation directly or jQuery. I mean, if you today announce that you love jQuery, the chairs next to you will be empty, isn't it? Because nobody wants to hang around with somebody who is excited about imperative style of programming that way. So we want to really move towards declarative nature. But I gave an example in the code level. I gave an example in the front end. But this is just not in just code alone. This is actually even more. For example, people drive cars. But I'll tell you one thing. I just don't care about cars. And don't get me wrong. I've got friends who love cars. And we are still friends. We meet for dinner. We just agree not to talk about cars because I just don't care about it. I go to a rental car company, and they will often ask me, what kind of car would you like? And I always say this, could you please give me ones with the wheels? And they will look at me and say, are you serious? I'm like, absolutely serious. Oh, don't you want to know what you drive? I'm like, I don't. Because I just don't care about what I drive. And I'll tell you, you will see me do a lot of stuff, but you will never, ever, ever see me drive a stick shift. I cannot understand why any human born on earth would ever want to drive a stick shift. This is the dumbest thing ever, in my opinion. Because you sit there and you keep doing this. I'm like, why are you doing this? You got to keep moving the clutch around. I got better things in my life to do than to be doing this. This is ultimate imperative style of driving. But then, a notch better than that is auto transmission. You put that on drive, take your hands off, and you hold your steering wheel, put it on cruise, and you can drive. But honestly, I'm not for that. I am more of a Uber and a Lyft kind of person. I get off the airport, I sit in the back seat of the vehicle, let the driver do what the driver is capable of, drive me to where I need to go. And I would open my laptop and I would start coding. And that's what I want to do. And the driver would ask me, which route should I take? I would say, take whatever route you want to take. Your job is to get me there safely. Do you want me to take a shortcut, a long cut? You know what? I don't care. You're probably going to save me about $2. That's not worth my time. Why don't you take me safely over there, wherever I need to go, while I do my work? And I can focus on what I am destined to do, and they can drive me around. And that is exactly what I want to do. That is declarative style of living. And this is not only that. Today, of course, we're talking about self-driving cars. So eventually, we are working so hard so we don't have to drive. We can focus on where we want to get to. So essentially, we are moving towards declarative in every aspect of life. Not just coding, not just front end, even in driving automobiles, that's where we are getting. What is the impact on us for all of this? Well, the impact really is everything we do becomes expressive. We can focus on what we want to achieve without focusing on the details of how to achieve that. And everything becomes really concise, easier to maintain, and we can engage with rapid change. So all this is great, isn't it? Well, it really comes down to economics. And one of the things I care about a lot today is economics of software development. 30 years ago, when I was a young programmer, I got paid to write software. Today, it is different. The money that I spend in writing software comes from this wallet right here. And if I don't think about the money I spend to write the software, I become poorer. So I think about economics of software because I'm not only a programmer today, but I'm also the one who is funding the programs being written for my company. And I'm very sensitive. What is the economics of software development? Am I wasting my money, or am I going to save my money in the long run? That is very important as well. Economics is extremely important. And that is one thing I always encourage programmers to ask. When you go to programmers, don't get me wrong, I'm a programmer, I love programming. And I'll sit down and talk with you endlessly about programming. But I always want programmers to answer one question for me. When you walk into your work in the morning, can you tell me what is your economic impact? How much money are you going to make for the company today? And I bet you 90% of programmers never think about it. Not that they don't care about it. It is just that they never have the opportunity even to think about it. Because we are so much worried about the API and the bugs we have to deal with. Sometimes maybe we don't want to deal with that bug after all, because it's not going to be cost effective to even deal with it. And we need to really keep that large scheme of things in our mind. What is the economics of software development? And let's talk a little bit about JavaScript. Why? Because we all love JavaScript, isn't it? JavaScript is special. It was created special in this world. Now, JavaScript is unique for a lot of different reasons. This is one language I would say is a great example of a black swan. If you have not had a chance to read that book, Black Swan, I highly recommend reading that book by Taleb. It's a great book because black swans are events that you never, ever expected to happen. But when they happen, they change everything around us. There are good black swans and there are bad black swans. I'm still trying to debate what JavaScript is. But JavaScript is a black swan. And JavaScript completely changed. We never expected. In fact, there was an interview of Brendan Eich, the creator of JavaScript, and he said he never expected anyone to take JavaScript seriously. And this is amazing in terms of, this is crazy because JavaScript was created nearly 20 plus years ago, maybe close to 30 years now. And in 2019, what is the most famous language on planet Earth? Imagine somebody fell into a cave 20 years ago, and they just rescued this person and was a programmer 20 years ago. And as they bring him out or bring her out, and the person asks, hey, what's the most popular language today? And you say, why? It's JavaScript. And the person says, you might as well throw me back into the cave. Nothing really changed, isn't it? Right? And I was trying to describe, how do you describe JavaScript? And here's my definition of JavaScript. It is like the bad villain in that movie. They keep killing him, but he keeps coming back to life over and over and over. And this is kind of scary in terms of how powerful this language is, and yet how menacing this language is, like that villain. But how many of you use JavaScript? Yeah, everybody, isn't it? And when you're trying to use JavaScript, how does it feel to use JavaScript? It is really this, isn't it? It is actually a chainsaw. And you ring it up, and you're like, oh, be careful where you swing it, isn't it? Because it can become really dangerous. And I wanted to describe JavaScript, and here's my definition of JavaScript. And don't get me wrong, I love that language. But also, it's a language that is pretty menacing. And the other day, I had written a piece of JavaScript code. Everything was working fine, and suddenly it didn't. And now I'm trying to figure out why it doesn't work. And then I was in the frustrating moment. Most of my tweets, I tweet when I'm really frustrated. And so I stopped debugging JavaScript, and I tweeted this. And this is my tweet. Here's my definition of JavaScript. So how do I describe it? JavaScript is like an infant. It is cute to play with, but you have no clue why when it begins to cry. And this is how I feel about JavaScript. It's kind of like the little baby, isn't it? And the baby is crying endlessly. You call mom and say, Mom, the baby is crying. What do I do? Have you checked the diaper? I did. Have you fed the baby? I did. Are there any insects nearby? I checked. Now you're debugging the baby with the mom. That's exactly how it feels to work with JavaScript sometimes, because you're like, why wouldn't it work? Well, that's because JavaScript is weakly typed and dynamically typed as well, and that can be really frustrating. Well, with that said, it's a slippery slope when we are working with some of these higher level of abstractions and languages that are really dynamic typed and weakly typed as well. Now, people say, we can solve this problem really, we could use TypeScript. Well, keep in mind, TypeScript compiles down to JavaScript. So TypeScript is statically typed, but it's also weakly typed when you run it. Unlike languages like C# and Java, which are strongly typed at runtime, TypeScript is still weakly typed at runtime. You still have to deal with the dynamic nature when the code is running. So in that regard, well, leaving those thoughts aside for a minute, we are living in this world of agile development today. But what does agile really mean? I'll tell you what it doesn't mean to me, first of all. Agile is not stand-up meetings. Agile is not about Scrum Masters. I don't even know why we have Scrum Masters. But I go to companies, and they proudly announce to me, oh, I'm a Scrum Master. I'm like, I'm really sorry to hear that. It's like, why? I mean, this is the funny thing in this world. We create something, and rather than using it to solve real problems, we put ceremony around it. And then we drum and beat around it. And what is stand-up? It's a ceremony. What is a Scrum Master? It's a ceremony. And I'm going to ask, are we being adaptive? Are we releasing software that's meaningful in a way it can be reliable? And we leave alone the essence of agility, and then we drum around all the ceremonies. That's what we are focused on as humans. We love these ceremonies. And I'll tell you how I feel about Agile. I'm a big fan of movies. One of my favorite movies is a movie about Moses. And in this movie, Moses comes down and says, Joshua, you take care of the people. I hear voices up the hill. I'm going to go up. And Moses has gone up the hill. And here Joshua is like, what do I do with these people? And by the time he comes back, what these people do get together is they collect all these jewels and they melt it and they create a statue and they celebrate it. And every time I watch that movie, I say, that's agile development. Because that's what we do. Moses went up the hill and we said, let's bake this all together and create a statue. And we celebrate this ritual of stand-up meetings around. Now, but is that what Agile really is? Well, to me, Agile really is ability to respond to change. And to be able to respond to the change even late in development. And that is the key, is to be able to respond to change even late in development. But how do you respond to change late in development? Let's think about this for a minute. You have a volume of code. And when you have a volume of code, if you make a slightest change to a code, software is a nonlinear system. You change something here, something breaks over there. And that's what we do every day, isn't it? And this is the fun part of being a programmer. You change a code here, and that table just fell flat. And then you debug that. And then you share this with your colleagues. You know what? I changed this code. How funny, that one failed. And they all get together and say, tell me how you did that, right? We are so excited because it's phenomenal. That's the beauty of software development. It's non-linear. You change something here, something breaks over there. Now, the problem is, you make a small change in the code, you got to test the whole damn thing again. You cannot just check the part you changed and walk away. And that is expensive. But then what happens? Well, you make a change to code. Your team, your colleagues, your boss, your team leader, whoever it is said, fix these bugs, make these enhancements, and add these features. And you finished it. And then they ask you this question nobody likes. What do they ask you? Does it work? And I'll tell you what's the most famous answer we give. I hope. This is amazing, isn't it? I hope. Actually, there's a technical term for that I hope. It is called JDD, which stands for Jesus-driven development. We put the faith in the Lord and say, dear Lord, please let my code work today. So that's what we practice. We practice Jesus-driven development. And don't get me wrong, I have faith in the Lord as well. But I think the Lord is way too important to spend time on the stupid code I'm writing. I would rather do TDD than JDD. But that's the problem we live in, is that we tend to really go rapid, breakneck speed. What happens if we go at breakneck speed? We break the neck. And that's exactly what we are doing in our field, is we discard all the disciplines we need, and we are just focused on the speed without sustainability. And I'm going to say, don't bother testing software. If it does not work, your users will tweet about it. I wish I had taken a photo of this. I was speaking in a conference, and I was extremely tired by the end of the day, and I totally forgot to check into my airline. And so as I was about to hit the bed, I said, oh my gosh, I forgot to check in. And I took my phone, went to the airline's website, and I'm not even kidding with you. On the website, I saw two curlies like this with variable names. And I remember saying to myself, oh, how sweet, you airline, you're using Angular. And that's the last thing I remember. And then the next morning, I'm like, oh, darn it, I should have taken a photo of it. And I went back to it, and the page is refreshed already, damn it. But the point is, you can tweet about it. Well, I was trying to define our profession. I'm going to give you the definition of being a software developer, but I have a request for you. Please don't tell this to anybody. This is our little secret, because this is what makes us really happy. And I'll tell you what software development really is. A software developer is the one who works in the profession of software development, a profession where people get paid to write poor quality code and get paid more to clean the mess up later. This is the best job on planet Earth. Never tell this to anybody. We get paid many times to do the same thing over and over and over. This is the luxury, isn't it? Because this is the beauty of the companies we work for, right? You go to the boss and say, boss, I need more time to do a good job. No, you don't have time. You got to release it tomorrow. And we create this absolute mess. And they're like, how much time you need to fix it now, right? And we can keep milking this cow over and over and over. Why should we change when this is the luxury we have in our industry? And you say, what about ethics? Oh, I forgot that one. Unless we as professionals are ethical and moral, nothing is going to change for us. Because that's the field we live in. That's the hypocrisy we live in, unfortunately. Well, talk about testing. Well, testing, I want to emphasize one thing before we go any further. And here is a tweet I made one day. And I want to kind of mention that before we talk about this any further. I do automated testing not because I have a lot of time. It is because I don't. And that is one thing I want to emphasize. People often say, oh my gosh, automated testing is going to take time. No, it actually saves time. Now, one of the reasons why we find it so hard to do automated testing is because most of us have not been given the time and the resources to get better at it. Now, this is human life, isn't it? Have you ever done anything in your life, honestly, where you did it the first time and you nailed it? Never, isn't it? Well, you do something and you say, I suck at it. You do it again, you suck more. You do it a third time, it feels better, but I'm still sucking. And then about 30th time, hey, that's not really bad. And that's how we get to where we are. And this is true about everything we do. If you are capable of writing bad code, how could you suddenly be capable of writing good test? We're going to write bad test to begin with. And we need to take the time to learn and get better. It's kind of like trying to tell somebody, oh, bicycling is so easy. If you take a bicycle, you can get there in 10 minutes. And the person says, really? But I don't know how to ride a bicycle. You cannot get there in 10 minutes. You got to first learn bicycling. And the older you are, the harder it is to learn bicycling. Well, kids learn bicycling in no time. You put somebody like me to learn a bicycle, that's going to be really hard. The more experienced you are as a developer, the harder it is to learn testing. Why? Because learning something like testing is one part learning and several parts unlearning. And unlearning is more difficult than learning. And unlearning takes very deliberate effort. We have to replace our bad practices with good practices, and that takes a lot of time and effort as well. But a lot of times we are never given this much amount of time and effort to get better at what we do, and as a result, we say it takes more time. Yes, it takes more time because we haven't gotten better at it, and once we get better at it, it actually ends up saving time for us. And I'm going to say, I love manual testing. And you're going to look at me and say, really? Oh, yes, I love manual testing. But here's my definition of what testing really means. So what is really testing? To me, testing is an act of gaining insight. That's what testing really is. It's an act of gaining insight. Hey, should we really be doing this workflow at all? Should we look at this user and ask this data, or should we just wait until later to get this? Is the forms really the way it should be? Should it be structured differently? Can we eliminate a few things from our process? But then, what are we interested in a lot of times? You wrote a code yesterday, it worked. You made a change to the code today. And the question we ask is, it worked yesterday, does it still work today? That is not testing. That is not exploring. That is not gaining an insight into what we are doing. We're asking, stuff worked yesterday, does it work still? And to me, that is verification. Verification is simply asking, it worked yesterday, verify it works today. And that's not testing, that's verification. And so when we use the word testing, we group everything together. And verification, does it still work? And no human should ever be asked to manually verify if the code still works. This is an insult on humanity. To go to a human and say, waste your precious life to tell me the stupid code I wrote yesterday still works. And no human should be ever asked. That's beneath the dignity of any human, in my opinion, to verify if the code actually works. Machines should be checking that, not humans. We should be able to automate that and run through, not have them. To test manually, verify automatically. And we want to be able to get this verification, and once we gain the skill for doing this, it becomes the way of writing code. It becomes the way of thinking. It becomes the way of our culture. Then we are able to gain sustainability in what we do, rather than saying it takes more time. It doesn't take more time once it becomes the way of our life. Just like somebody says, it takes time to shower. It takes time to brush our teeth. And if we ignore the hygiene, we end up in the hospital. Not only we end up in the hospital, we take a few people with us because we spread the germs. That's exactly what happens in work. The code we write with poor quality with no test not only affects us, more than it affects the entire team. It brings them down as well. I'm going to say there are 3 phases of verification. I go around the world. I work with different companies. And if you ask me, I've seen 3 different things so far. The first phase is no automation whatsoever. And there's a lot of companies who live in this world today. You go to their teams and say, how much of automated tests do you have? And they kind of whisper, we don't have any automation. Or they say, we have automation, but we don't know when we ran it. And they don't have really good way to automate their tests because they believe in writing code and going home, not in giving a feedback loop. But what is agile development? It's feedback-driven development. If we don't have a way to get the feedback from the customers and from the code, what good is it to be agile? That's the first phase. The second phase is, yes, we do automation. But unfortunately, how do these companies do automation? These companies have realized that automation is extremely important. But then what they do is they go hire a person with the title automation engineer. Beautiful title, isn't it? So the automation engineer shows up to work and says, hey folks, I'm your automation engineer. And the programmers are busy programming. Hey, welcome to our company. Now leave us alone. We are busy fixing bugs. And the automation engineer goes around, and the programmers don't want to talk to this automation engineer because the programmers are so busy doing their stuff. And a month goes by. The boss goes to the automation engineer and says, hey, you've been here for a month. Wednesday at 2 o'clock at my office. I want to see what you've done for automation. And the automation engineer says, darn it, I'm in trouble now. The programmers don't want to talk to me, and the boss wants a result. What do I do? And the programmer looks around and finds this beautiful, beautiful solution. It's called Selenium. It's amazing. So how do you define Selenium? Here's my definition of Selenium. It's called the pathway to hell automation. Because when you put automation on the front of your UI, what happens? It's shaky and brittle. And I see a lot of companies jump on that bandwagon. And I've only seen 2 companies, those who have failed and those who are about to fail. And those who have failed, I always go to them and say, how are things going? Oh, we used to have all these automation running. We don't run them anymore. Why not? Because these damn programmers changed the UI and we couldn't run this anymore. And so that becomes what is called the mostly UI level verification is really a pathway to hell automation. And this becomes extremely brittle. And this is one area where the automation engineers have to collaborate with developers, programmers rather. And we have to live together, work together. Isn't that the spirit of agile development? Is that we are one team working together for one cause. So we shouldn't have these distinctions. You versus me doesn't make any sense. So you want automation at the right level. Now this is called, we do stupid things, but we give beautiful names for it. This is called the ice cream cone pattern. It doesn't taste like ice cream. Ice cream cone pattern is where we do most of the test either manually or at the UI level, and fewer tests automated at lower levels. This is fundamentally flawed, but a lot of companies try to do this. But instead, what we really want to do is we want to do automation, yes, at the right level to the right measure. We don't want to automate just blindly for the sake of automation. It's got to be at the right level, but it's got to be at the right measure as well. And this becomes what's called the test pyramid. The test pyramid says you do want automation at the UI level, but the automation at the UI level should not be the most. In fact, I'm a big fan of analogies. And here's my analogy. To me, integration testing and UI level testing is like salt in a meal. You cannot have a meal without salt, but you cannot make a meal out of salt. So if most of your testing is at the UI level or on the top, front end and manual, that's like giving somebody a meal of salt and saying, take it. And people cannot do this. And similarly, it's dangerous to health. And this is dangerous to the system we are developing as well. So the test pyramid essentially says we need to automate at the right level to the right measure. So why is this so hard, though? Why is it so hard to really spend time to automate these things? Because it's a skill. And when you hear people say, this code is really hard to test, these are called euphemism. Programmers never tell you the real truth. They say this code is really hard to test. What they're really telling you is the design of this code sucks. Because the code that's really poorly designed is really hard to test. So testability is a design issue. If we design the code properly, it becomes testable. And if I were to write a test, and if I'm not able to write a test on a piece of code, then what happens? Let's think about this for a minute. Raise your hand if you think a long method is a good idea. Not a single person raised the hand. One person raised the hand, but scratching the head. Why am I even asking this? Okay. Let me ask you a completely different question. Raise your hand if you see long methods at work. Yeah, the hands go up right away, isn't it? Well, that's called cognitive dissonance. We know not to do it, but people do it. Now, how do you write a test for a long method? The number of permutation and combination is so many that we possibly cannot write the test. And the boss says, don't worry about it. If it doesn't work, the users will tell you that. Well, it's a testability. If the code is poorly designed, we know long functions are poor design. Why? It lacks cohesion, and it has too much coupling. Well, poor design is hard to test. So that's an early sign of warning. Hey, how good is your design? How good is your automated test? You know, when people tell me, hey, we have automated tests, let me show it to you, I often tell them, don't bother. Don't show me your automated test. Show me your code. I can tell you how your tests are by looking at your code. Because the structure of your code is going to be very different if you have automated testing on it. And so as a result, the design, it's a design concern from the point of view of testability in reality. So hard to test a large piece of unknown. You know, one of the problems oftentimes we have is, you know, I go to programmers who are brilliant. Honestly, these programmers are brilliant. I would give them a problem and say, can you write a code for this? And they'd come back in a few hours and say, I'm done. I would go to these same brilliant programmers and say, hey, write tests first and write code after. And they look at me and say, are you an idiot? I can't do it. And I always wondered, why is it that these brilliant programmers are able to write code, but they're not able to write test and then write code? Why? And I was struggling with this because I know these are good programmers. Why are they having such a difficulty? And it eventually dawned on me, what is really programming? I mean, do you ever work with a programmer who says, oh, I'm going to code? It works, bye, and they go away. Does that happen? No. Programming is, to me, a series of mini experiments. Hey, let me write this code. That's not working. Let me try this. That's not working. Let me try this. That's not, bam, bam, bam. Look up this API, Stack Overflow, right? And talk to your colleague. Oh, I think this is going to work. Still not working. And then eventually, it looks like it's working. Is that what our life is? That's exactly what we do, isn't it? Programming is a series of mini experiments. We explore, we find, we observe, and then we got a piece of code working. And when we are doing that, if I come to you and say, I got a great idea for you, write test and write code. Like, are you an idiot? I don't even know what I'm writing. How can I write a test and write a code? And then I realized, oh, so now I understand why we are not able to write test and write code. What if we do an active prototyping? So when I start with an unknown, as an example, a few years ago, I had to write a piece of code for the very first time to go talk to Amazon S3. And I'm like, gosh, I've never done this before at the time. And how do I write a test and write the code for this? I don't have a clue. I said, okay, leave the project here, don't touch it. And I went away, far away from it, created a standalone little prototype, a little example that puts something into S3, gets something from S3. I played with it. Hey, I kind of know how this works now. I've done all that banging on the keyboard and looking at other people, looking at examples and tutorials. I know it's not an unknown. Great. Leave this prototype now. Come back to my production code. Test code, test code. So if you can remove that unknown, if you can use that little experiment, what is that called? We call it spiking. Spiking gives us an ability to explore an area, and then we can come back and write test and write code. And a lot of times, we don't do this active spiking. If we don't do an active spiking, we get frustrated. We're not able to write test and write code. And in the end, we end up with this massive code with no test on it. But what if we have the discipline to spike the code separately and then come back and write the code with automated test? That can change the way we think about things and how we want to build it. So take small steps, divide and conquer, but more important, spike to learn. And when you spike to learn, you can then say, I am going to explore this unknown because it's completely vague in my mind. If I've done this 70,000 times, maybe I shouldn't do it again. I should reuse the code. But if I've done this before, I should spike to learn from it. And then I have to come back and write the test and automate that. And that will change the design. And every time I do this, my spike, my prototype is very different structurally compared to the code I end up writing because I write this code with test. And it influences what I do, but the test influences the design of the code I'm creating as well. So is Java code really verifiable? Absolutely. We can write the code so that we can have different number of tests at different levels of our code. And I got really excited about this, and I kept hearing people ask this question over and over, and I decided to capture that in, this will move, and I decided to capture that in this book on writing automated test. So this is purely about test-driving JavaScript applications. How do you write tests for JavaScript? And it's just absolutely a method to the madness. How do we approach by writing tests and getting this automation going? And we can approach that definitely if we have the discipline. It is just a skill, like a lot of other things are skills we have to develop. It takes discipline. And this is probably the one that is the most deficient in our industry, is to have the discipline. It does take time, especially in the beginning, until we get better at the skill. And it's a skill we have to take the time to practice as well. But that comes from having a culture in our organization where we do have this culture to create automated test. And I'm going to say automated verification is the software equivalent of exercising. If I ask a group of people, how many of you, and you don't have to raise the hand for this, if I ask a group of people, how many of you think exercising is a good idea, almost everybody will raise the hand. But if I ask how many of you really exercise, many hands will not go up, isn't it? Why is that? Because we all have excuses, like I once did. When I was a young programmer, my wife, very caring, told me, Venkat, you're working too hard, you have to exercise. I told her, are you kidding with me? I got important things to do. I got bugs to fix. Can you imagine leaving a bug and getting on the treadmill, you'll hate your life doing it. I can't do it. I got proposals to write. I got books to write. I got articles to write. I got better things to do. And she did what any sensible person would do who cares about you. She one day went to the store and brought a treadmill. And I come home, I opened the door, I stumbled on it. I said, oh, what's that? She said, that's a treadmill. I said, I know what a treadmill is. What is it doing here? Oh, Venkat, I went and bought it for you. So you don't have to go to the gym and waste your time. It's right here for you. I said, aha. I took the back door from then on to come into the house. And she did what any sensible person would do. She said, whatever, and left me alone. And a few years went by, and I was driving home at 1 a.m. after speaking at a conference. As I'm driving home, I can feel pain in every part of my body. I'm like, gosh, something is wrong with me. And I ignored it. And this went on for about 3 months. I said, you know what? Something is really wrong with me. And I went to the doctor and said, Doc, something is wrong with me. Fix me now. I got important things to do. I got to fix bugs. So the doctor said, oh, we'll do every test, MRI, blood test, this test, that test, everything ordered. Oh, here's some pills for you to take in the meantime. Come back next week. And I went the next week with my wife with me. And the doctor said, hey, I've given you the best muscle relaxant. And I look at your record. There's the record of a healthy person. You have no problem at all. So you're going to tell me that you don't have the pain anymore. I said, you're like programmers. You're debugging the wrong stuff. I'm still in pain. And the doctor said, well, you're not going to like what I'm going to say. I said, Doc, it doesn't matter what you're going to say. Tell me. I don't care how much it's going to cost because I got to get back to being healthy. He said, no, it's not going to be expensive, but it's going to be really hard to do. Like, how hard could it be? He said, well, nothing really exciting, but you got to get on the treadmill for about 30 minutes a day. My wife was sitting there and rolling her eyes. You idiot. I told you this a few years ago. And I came home. You know what? I don't like treadmill. This is the stupidest thing you can do as a human being. You're walking and you never get anywhere, right? And I got on it. 3 days, I got on it. 4th day, I was sitting and working. My wife came along and said, hey, how's it going? I'm doing great. How's your pain? Oh, it's gone. Did you work out today already? I said, look at me. I don't need that nonsense. I'm fine. And she's like, oh my gosh, I cannot believe you. 2 days went by. Oh, it's hurting a little bit. Let me get on the treadmill. 4 days goes by. I don't need this stuff. 3 days later. And then I said to myself, wait, there's a pattern here. What if I get on the treadmill, give that 30 stupid minutes to the treadmill? Hey, the rest of the day, I can be bouncing around. I don't have any pain. Take some time to learn. This is what automated testing is. Most of us don't want to do it, but still we endure the pain. So that's a software equivalent of exercising. In the year 1820, I'll take another 5 minutes and be done. In the year 1820, there was a huge mortality. If a friend of yours came to you and said, I'm going to have a child, should I go to the hospital or should I have the child in the bathtub? In 1820, you will tell your friend, bathtub, I want you to live. The mortality rate was very high. Why? The doctors back then walked around with blood on their coat. If a doctor was a really, really good doctor, they'll have more blood on their coat. A guy named Semmelweis figured out germ theory. They didn't have microscopes to prove it. And they killed him. They said, you speak against authority. What do you know about germ theory? Have you seen germs? No. Well, how do you know? Well, Semmelweis did something different. He took all his tools and he boiled them in water. And then he performed surgery. And he used new clothes every time he went to do surgery, wash clothes. His patients were not dying as much as other patients were. So he had an empirical proof, but they didn't believe him. They killed him. And several years later, Joseph Lister and Louis Pasteur came along, and they said, that guy you guys killed, he actually knew what he was talking about. And that's when they popularized germ theory. And they changed, and radically the practices we use came along in 1850s. We've not been doing medicine like the way we do for too long. It's still only 150 years ago we started sterilizing what we are doing. And I'm going to say in our field, we are living in 1820s today. We are in absolute denial. We create poor quality. We're not doing what is sustainable. we're in denial. And hopefully, that'll change as we become mature and we can move towards a modern time. We're practicing a beautiful craft. This is a gift given to us, in my opinion. I love what I do. I don't want to, the only two things in my life I truly enjoy doing, hiking the mountains and writing code. And writing code is absolute joy because I can take things in my mind, I can make them to come to fruition, I can refactor it, and it's a pure joy to be able to see the code working in front of you. It's a beautiful craft. Let's go turn that into a wonderful profession and practice it wisely. Hope that was useful. Thank you.